Hello everybody. In this video we are going to be looking at the solution to the honors electromagnetic induction due right now number 2. Everybody's sleeping right now so I can't shout, but I miss it. I do miss it when I don't do it. All right, let's take a look at the problem. We are told that we have an induced EMF of 0.089 volts, and it is induced in a 5.0 centimeter wire when it is moved perpendicular to a magnetic field at 2.1 meters per second. What is the magnitude of the magnetic field? Let's take a look at what our given values are. We are given an EMF of 0.089 volts. So that's what this is right here, EMF of 0.089 volts. EMF stands for electromotive force. And for our purposes, we can treat that like a voltage. It's a voltage that is produced by moving the wire through a changing magnetic field or in relation to a magnetic field, as opposed to a regular voltage which we got in a wire by connecting it up to a power source such as a battery. So it is what we call an induced EMF. And because it's an induced EMF, we're going to use this symbol here, this E, this funny looking E here, to just differentiate between an induced EMF and a regular voltage that is created by connecting a wire to opposite ends of a battery or a power source of some sort. We are also given the length of the wire at 5 centimeters. So we have to convert from centimeters to meters. So that's going to give us a length of 0.050 meters. And we have a velocity of the wire at 2.1 meters per second. We are looking for the magnitude of the magnetic field. So in order to find the magnetic field when we are given the EMF, or the induced EMF I should say, we know we want to use E equals BLV, which Mr. Broderick reviewed with you guys in the PowerPoint narration. We want to solve this for the magnetic field, so doing that is going to give us B is equal to E divided by L times V. We plug in our known values and we are going to get a magnitude of the magnetic field of 0.85 Tesla. Okay, let's take a look at the second part of this problem. And they want to know if the resistance in the wire is 0.45 ohms, what is the current in the wire? So if we're given the resistance of 0.45 ohms, we are looking for the current. So if I have the resistance and I want to find the current, and I have the EMF, which I got from the previous part of the problem, or I'm given from the previous part of the problem, I know that I'm going to want to use Ohm's law, V equals IR. Now remember I told you that the induced EMF, which we represent with the funny looking E, is the same thing, or we can treat that the same thing as a regular voltage. So I can swap it for the voltage in Ohm's law. When I do that, I'm going to get the current is going to equal the EMF divided by the resistance. And when I plug my values into that equation, I am going to get a current of 0.20 amps.